Welcome again. We are in the next part of the tools and platform track. And the next speaker is Radu, who is a core member of the Knowledge Graph Solution team. He will give us a practical demo how to reconcile data or map strings to things with zero coding by using GraphDB and the Ontotext reconciliation service. So the question is, can we use semantic context to do a smarter, faster, and more accurate data integration? Perhaps this is the way how to integrate data and activate its metadata. If Wikidata, which we saw today that it counts more than 10 billion triples, can be this way, why not building your enterprise graph the same way? Let's see what Radu has planned to show us. Radu, the floor is yours.
Thank you for the introduction, Vasu, and good afternoon, morning, evening, whatever the time may be for all of our attendees. I hope that you've been enjoying up to now what you're seeing, and I hope that you'll continue enjoying it during this session and afterwards. So without further ado, I'm just going to start sharing my screen, and I can show you all the information which we want to show you. So this is the title of the demo, the Ontotext reconciliation service. The idea with the reconciliation service is to arrive at a holistic view of your data, like a whole view. In this case, you want to know about the metadata, you want to know about what sort of data you have, you want to know everything about it. So what we're going to cover here is what reconciliation is, what services there are already, and what's a reconciliation service definition, and what we do in Ontotext specifically for reconciliation. Then we're going to have a quick demo. So what reconciliation is, I hope you will excuse us if that's old information for some of you, but maybe some of you are not familiar with it. So the idea is, to start with an example, we want to make a database about famous pictures. And we call that database EX or something like that. And there's already a lot of information about pictures, but it's in different data sources. Some of it is in Excel, in text, in CSVs, RDF, SQL data. It's in different languages. There's a lot of great information in English, and it's the biggest Wikipedia size. The most information is in English, but there's a lot of information in French or in German, which won't be available in English. There's different APIs. Maybe there's an Excel API, there's Google Sheets API, there's a JSON-based API. Well, and we get some strings, some IRIs, we learn about family portraits, we get this thing, which is, I'm not sure if it's Chinese or Japanese, to be honest. I think it's Japanese. We get this beautiful Wikidata IRI, which is very informative to some system. Unfortunately, to us as a person, it's not that informative. We get EX, awesome photo, which is our own database. But you know, all these are actually the same picture. And it's all the family portrait of the Voyager spacecraft, which, as it's flying away from the solar system, it's taking picture of all the planets. Of course, you don't see Pluto here because it's got its planet status revoked. So reconciliation is the movement towards a unified data model, because when we have different disparate data sources and disparate data bytes, so to speak, when we have different data bytes, we can't really argue about them. When we have one model and we have one way to store that information, it's much easier to argue about. For example, if you know that John Smith is 1.8 meters, that doesn't help you with the health information on John in any way, shape, or form. Now, if you have that information within your model, and within your model you also know what his blood type is, if you know what his age is, if you know what his birth date is, you can start drawing from that information. You can start drawing knowledge about the health status of John Smith. And this process of moving from John Smith height 1.8 towards having it in your model and knowing things about it is called reconciliation. So there is a very well established, because as I mentioned, it's not a new problem. It's been around for a while. There's a very well-established reconciliation standard for how a reconciliation service should be, and many places implement that standard. I'm not even going to pretend that I know all of them, but I know the first few: Wikidata, which is the big one, so to speak. And the good thing about Wikidata is that it's really diverse and big. There's VF, ORCID, Open Library, Getty Vocabulary, Open Corporates, which is corporate data, GeoNames, locations, Ordnance Survey, again, locations. And then there's some strange reconciliation services, which are not so standard, and they're very specialized. Like, I think that there's a taxidermy service there somewhere. And the way in which I know of all of them, including the weird ones, is the reconciliation service test bench. Here you are able to put in some specific triples in Wikidata, and then Wikidata is now starts knowing some tests against it. So, for example, you can see, I don't know if my mouse is visible, but you can see that Getty doesn't support suggesting entities, doesn't support suggesting types, whereas Wikidata, of course, being the leader, so to speak, in this, supports all the various APIs. And you can see there we have 3 more entities down here: Ontotext, Wikidata, People Service, Ontotext, Wikidata Organizations, and Wikidata Location Service. And you start wondering, well, Wikidata has information about POL, people, organizations, and locations. It's already there. So why have Ontotext separate? Is it just for demo purposes, or do we actually mean something? Is there any difference? Well, public services are great, but they have some obvious drawbacks. For example, they're public, so availability can be a problem. If tomorrow 100 people decide to use Wikidata reconciliation at the same time, I wish that they do, because this means that the service is very popular, it's getting used. But besides it being great for its popularity, it would also mean that performance will probably suffer. It may even become unavailable. And also, you as a person who uses Wikidata, you won't be able to track your own requests through the Wikidata reconciliation service. Whereas if you're using your own in-house solution, you'll probably be able to. And then there's HTTP overheads. I've had one client which was geographically at the other end of the earth, and even opening their wiki page was painful. It took 10 seconds to load a basic HTML page. Imagine this with transferring a lot of data for that reconciliation service. But all of those things are non-functional requirements, so to speak, and you can sort of work around them, but ultimately, functionally, you are using Wikidata schema. Whereas if you have your own service, you can use your own schema and your own data, because maybe you don't want to reconcile Wikidata information. Maybe you have something very specific. Maybe it's information about, I don't know, animation from the 70s, Mickey Mouse, Tom and Jerry, that sort of things. And you also have your own schema, so you don't want everything to be mapped to Wikidata. So you can use our service. What here is a demo of how the architecture looks. You have GraphDB at its core, and you have some utilities connected with GraphDB. You have data pre-load and update. We are always up to date with Wikidata for a demonstrator, but you can have a pre-load and update for any other sort of data. You can have security, creating connectors, you can manage connectors, and Elasticsearch is the other major part, which you can look at with Kibana. Then there's the conciliator, as we call it, which is just the reconciliation API, the Ontotext reconciliation API. Just to differentiate it a bit internally, we call it conciliator. And it's publicly available with the Wikidata demo, to be precise. It's not publicly available with your own data. That would be amazing, but technically not possible at the moment, at reconcile.ontotext.com. And you can connect any refined client, in fact, anything not only Ontorefine and Ontotext, but anything which works with the reconciliation API or machine learning query benchmarks to it. Like, this is how we optimize it and benchmark it with machine learning. Now, what are the benefits of this? Well, we load RDF data, but we expose it as text seamlessly. You can have different configuration for the GraphDB connectors, and the good thing is that mostly people try to reconcile text and CSVs in our example, but RDF is not amazing for reconciling text. This is why we can expose it with a text index, with a text search database like Elasticsearch. You can also have RDF rank, which is telling you how well connected and how popular, so to speak, an object is. You can think about RDF rank as page rank in Google. And this utility, in fact, can help you augment the scores. So things which are higher ranked get a better reconciliation score. So, for example, if you get New York, the city, the state, and the county, if there's a New York County, I'm not exactly sure, they'll have different ranks. And if you include this rank in your scoring, you have different results based on how popular each entity is. Elasticsearch, the fact that we use it means that we can scale easily, it performs well under stress, and scales a bit differently from GraphDB. GraphDB scales horizontally on the number of concurrent reads, whereas Elasticsearch can also speed up reads depending on how you scale it. It also has configurable preview templates. You can have various HTML bits, which we're going to discuss a bit later, because a preview template sounds a bit foggy, but I can actually show it in the demo. And you can configure those. You can input any HTML there. And it's also versatile. You can update GraphDB data with Kafka, Sparkle, GraphQL, roll triples, Ontorefine. We are actually introducing smart updates in GraphDB 9.10, and we're going to look into improving them in the future. So there's also customization for Elasticsearch queries. And by default, we have a decent default sort of checkup and default query, but you can go really in depth with Mustache and have really in-depth customizations. For example, here we have customization on located in, which is an optional field that gives you a boost of 5. We have type as an optional field as well. And if you match the type, it would increase the quality, because you may decide to match without any types at all. And the only required field is pref label. Now, this customized template can be huge. I've just chosen a relatively small one so I can fit it on the screen and you can kind of ingest it. Because having one of our custom templates with which we tested, it would not even fit in the first place, let alone you taking the time to understand what's going on. Now, moving on to the main part, because after all it's called a demo, I'm going to show you the demo. So we're going to move on with Ontorefine, and here we have information about Fortune 500. Now, Fortune 500, I'm going to redo all my actions. Now, you can see that this is a data set from 2017, which is going to become a bit relevant in a short while. Now, I'm going to start reconciling different bits of that data set. I'm going to start with the CEO. Now, the CEO, you are able, with the reconciliation API, to give it hints, so to speak, which give you different fields which you can add. So if I open up the CEO and I look at people, it's human, and it's count 300 and score is something else. You wonder why the count is 300. Well, the thing is, it takes 100 cells at random from this data set, and the 100 is the default. You can configure it to something else. And then it searches for their types in your reconciliation API. And for the 3 top types, it returns them here. So all of those entities, all those 100 cells, all of them are human. And all of them, all the 3 top results are all human. So we get that. And here you can use relevant details from other columns, and you can use them as properties. The thing is, this is a company data set. This is company CSV, sorry. So you don't get the birth date of the CEO, you don't get the birth location of the CEO. The CEO title is not relevant, unfortunately, to this one, because remember that this is not the big Wikidata, which stores everything. And it's amazing because it stores everything, and the reconciliation API is really powerful. This one stores particular subsets of Wikidata, which allows it to perform better. So I'm just going to reconcile it against human without any additional fields. And it's now reconciling all 500 rows. And let's look at the results. Douglas Macmillan, this is Doug Macmillan, and this on the right here, you can see the preview. And that's what I meant by customizable HTML template. Here, it's really good looking. With Wikidata, you get the image, you get the link, you get the small description. You can do anything, so long as it roughly fits the page. You can customize it in any way, shape, or form, this entry. So Douglas Macmillan, I believe, was the C. Douglas Macmillan. Doug Macmillan is the suggestion. Walmart, and it says in his quick description that he is the CEO of Walmart. That sounds about correct. And here we have the first example of why being with a smaller data set and more performant has its drawbacks. This is Warren E. Steller, who is the head coach of something called Berkshire Hathaway. Whereas if we look at it like that, oh, Warren E. Buffett. Okay, what's going on? Well, if you look at our source data, you're going to see that we have indexed Warren Buffett without the middle name. So what we have is, because we don't have any advanced analyzers on Elasticsearch and we don't have any customization on this query. This is the extremely basic default one, which you're looking at. It's not going to suggest Warren Buffett with higher priority because he's missing that middle name. And you see that his score is 32. For Warren E. Steller, it's 34. So it automatically says, okay, the score for this is the highest. There are no draws. It's the absolute highest. So I'm going to just select that. Okay, we're going to tell it, no, that's Warren Buffett. And you can see that not all of them matched. Again, this is because we're missing any context. And if we move to companies which are further down the list and they're not so successful, so to speak, you're going to see more oddities like that because, again, we don't have any context for those titles. Now I'm going to move on and try to reconcile HQ state. Now you see that those states, they're all abbreviations, whereas the main field for what we've stored is the full name of the state. So when I try to go to locations, it's going to give me the generic location. It's going to give me first level administrative county subdivision, which sounds wrong. This is because, again, it's a smaller data set and we're reconciling only against specific entries and against the abbreviations. And the abbreviations are also indexed, but as a subfield. So what I'm going to do is, because I know that this is a state, and I know that the column title is state, I'm not going to give it city, town, or electoral district. I'm going to move all the way down to federated state. And it's going to reconcile quickly. And as I mentioned, we're also indexing the abbreviation of the state only as a subfield. And it's able to tell that, what was it? NE is Nebraska. It's definitely not the canton of Switzerland. So, and you can see that it's relatively decent here on the score. Texas is TX and so on. And I can do the same with HQ city. However, now I have context. So I can go to locations and I can go the state it's located in. So this location of the city is located in this state. So if I start reconciling, I'm going to see that all of those states were matched and all of those cities were matched. Great. And Irving, definitely with the weird square brackets, it's correct. San Francisco is correct. Cupertino, correct. Omaha. I'm not going to check all 500 of them, but I hope that they're all right. I've checked manually like a few dozen before. Now, the main topic, the main task here was to reconcile the companies themselves. So starting here, I'm going to reconcile the title, which is the name of the company. against the organization index. And well, organization sounds good. Why not? We'll start reconciling. And now we're going to discuss the few extra features. Now, first, there's faceted search, which allows you to look at different bits from the data, like all 500 rows. No, I just want to look at those which didn't match. Okay, and let's look at the second entry first. We have AIG, which AIG Lincoln, American International Group, Tata AIG. All of those would probably have the different HQ. So perhaps I have 17 things not reconciled. I can try to reconcile it again. Just going to go to organizations. And I'm going to do this. I'm going to reconcile headquarter, the state, and the city. I'm going to wonder why. Well, that's because in Wikidata and the way we've indexed it, you don't get necessarily the city as headquarter. You get the country, you get the state, you get the county, maybe you don't get the city. That's why I want to reconcile the headquarter against the state and the city at the same time. So I'm reconciling the title. It has a type organization. I can manually input some type, or maybe I'm going to say no particular type. But I think that organization is okay. And actually, I can also reconcile the industry. So you can have multiple different suggestions. Industry here. Start reconciling. And well, now we've moved on to 8. So we've successfully reconciled 9 entries. Now the next bit, which is problematic, is, hang on a second, lols and calls. What's going on here? Oh, okay, that's a weird apostrophe. It's not how we've stored the data. So what we can do is we can edit the cells and have this GREL transformation, which transforms this sort of apostrophe to that straight apostrophe. And we can now reconcile again the organizations. We're going to reconcile industry, and no doubt the main Wikidata endpoint would have performed better because we would have been able to tell you things, but it would have been much slower. And how much slower we're going to look at relatively soon. Okay, so we now reconciled calls and lows. They're reconciled, and well, we still have 5 entities which are not matched. What's going on? Well, I can tell you what's going on. A few of them, for example, Cigna, the data has changed. Those two are both health services and insurance. If you look at in the industry, healthcare insurance, so same industry. And Cigna, the correct one, is the American Health Service Organization. This one moved. It's no longer in Connecticut. I believe it's now in Pennsylvania. And this other one was in Taiwan. So it wasn't relevant in this case. Interrepublic Group of companies, Interrepublic Group United States, both of them have the same score because they have the same headquarters. So let's say that we want this one. CenturyLink and KeyCorp, I can open Wikidata for you, but the data changed. They're no longer named the exact same thing. KeyCorp is Key Bank, and CenturyLink I searched in Wikidata and it doesn't come up, unfortunately. DuPont, it's with weird capitalization, DuPont, DMPR capital, and unfortunately the DuPont company is going to come up, but it's going to have a lower rank than DuPont, the towns in Indiana, Ohio, Uzinco, Lucerne County, Pennsylvania. And the reason is that all of those are actually also organizations because they're incorporated entities. Again, that's the particularities of the data set. Still, I mean, 5 matched, 495 matched automatically, and with a bit of help, we've matched 497. That's fairly good. Now, I'm going to show you something else. So if I open one of the other projects, in this, I want to highlight that this is a completely random, that this is a completely random data set. So what I did is I indexed FSM, which is food food information dataset. And for the CSV to test against, I just Googled GitHub, give me recipes in CSV format. GitHub has this kind person who did some recipes in CSV. Great. We use that for testing. And again, we're going to try to brute force this with Wikidata. Ingredient O2, let's see. Yep, and this is Wikidata. This is not our own custom solution. This is not our own custom data set, which is well tailored to this. And the first entry was sugar. And it's suggesting me to do scholarly article. I mean, okay, I guess. Let's see what would happen. And that's the drawback of Wikidata, which we're going to see a couple of them. First, it's very broad. Like it has a lot of entries, scholarly articles which involve sugar, apparently. Water as well, definitely. I mean, sugar, water, scholarly articles with these are plenty. And second, because it's so broad and so big, billions of entries, it takes a while compared to our own data set. And yep, that suggestion about taking coffee with sugar looks good now.
Okay.
Okay, I mean, it's proposing to reconcile sugar with diabetes. That doesn't sound correct. I mean, there's a connection there. Sugarcane meal is the second proposal. That's the factory, actually. Sugar substitutes, not quite. I mean, there's palm sugar, sugar bowl, powdered sugar. Like this is the 1, 2, 3, 6th entry is what sort of works. And you see what the problem is. It's not our own data. It's not our own set of information. I'm going to clear this. And I'm not going to take much longer because actually this will be very quick. I'm just going to look at our language data, our food ingredients data, and see sugar matches to sugar. Now, because this is a random CSV, which I haven't done editing on, you know, not everything is going to match. Some things are like water. Water is not it is an ingredient, but it's for some reason not included in the data set because it's for food standards, I believe, and water apparently doesn't have the same food standard. But yep, there's water, clove, water, mimosa, sugar matched correctly. You have sugar substitutes, and that's the key point which I want you to take away from that. It's not as broad and as diverse as Wikidata, but first, it's very, very fast. You can scale it easily. Second, you can customize it with how it's searched particularly. And third, you can use your own dataset. This is against this data in this dataset here beautifully called test. But it's not Wikidata, it's your own thing. You can have it perform, you can have it customized, you can have your own data.
Okay, thank you, Rado, for the excellent presentation. Let's have some questions, and really the highlights is you take a GraphDB instance, you load your data, you set up the Elastic connectors, and then you're almost there. You have to set up the mustache template, and the reconciliation can be seen as a search and ranking algorithm. So the first question is, how do you represent RDF relationships in Elastic Index? I guess I'll give it to you.
Yes, this is done with the GraphDB connectors, and you're capable of specifying some filters. You're capable of specifying a chain of properties which map their literal value or their IRI as well. It's possible to a field inside Elasticsearch, and you can give it a custom name. The second question is, for reconciliation APIs available only as part of OnTotext? No, you can have those APIs against anything, so long as it can send a reconciliation request, it's good. And can we reconcile against our own vocab? that was the main takeaway point. Yes, you can.
Just to follow up, yes, it's not specific to the GraphDB's version of Refine. You can use it also against the Open Refine because this is a standard protocol. So it was great demonstration, converting strings to things. I guess we couldn't demonstrate how to patch this, but there is also a way to automate.
Yes,
Thank you for the fantastic presentation.
Thank you for your time.